Hey robotics folks, I'm just going to share with you, oops, I'm on the wrong screen. There we go. I just want to share with you the belt and pulleys lecture so you know what's going on for when that assignment shows up. So we've been talking about chains and sprockets, and a belt and pulley system is similar in some ways, but it's got differences. Alright, so a belt is a loop of something flexible, so like fabric or plastic, rubber and elastic is usually what they use. And it's used to link two or more rotating axles. In most cases that we're going to see in class anyways, the axles are going to be parallel to each other, but that doesn't have to be the case. And sometimes there'll be a twist in the belt as it passes between the pulleys. There you go. A pulley is a wheel that has a groove around the outside of it, along the rim of it, around which a belt or a cord can pass. So in an assembly, they're connected by a belt, the same kind of manner that sprockets are connected by a chain. It goes around the outer edge of it, and it will rotate as the chain or belt moves around, it rotates that item. You may have also heard of pulleys before in simple machines back in like elementary school or grade school, and you can use them to lift, and it provides a lot of mechanical advantage. But this is usually like they're used in multiple ways, and we're not probably going to have many that do the mechanical advantage thing. We're just going to use them to turn axles. Alright, when you got your gear ratios, you're going to have the same way of determining them as you do for gears, using the formula for diameter. And it's just like the formula for teeth. It's a ratio of the output diameter to the input diameter. And so as long as you know the diameter, then you can get that ratio. So there's a bunch of different kinds of belts and pulleys, and I actually found a whole bunch of information on an Instructables link, which is a weird place for me. I usually looked on Wikipedia to start with and then went into some mechanics websites, but Instructables. We got different kinds of belts or different kinds of pulleys and different kinds of belts. So there's drive pulleys, driven pulleys, and idler pulleys, just like when you're talking about gear trains. In this case, we got a driving pulley, and that's the one attached to the power supply, the motor or the crank or the pedals on a bike. You got the driven pulley, which is attached to the drive pulley by the belt, and you can have an idler pulley that really doesn't do much of anything except, take up slack on the belt. Pulleys can be fixed or movable. That refers to whether the axis is held still in place or not. If you look at this crane, there are two fixed pulleys at the top, and the thing that moves, the movable pulley, it's like on a block right there. It's like a block and tackle kind of thing. When we're talking about mechanical systems, we're going to talk about fixed pulleys. They're going to have axles that are mostly fixed in place, and they're not going to be used to provide mechanical advantage like a movable pulley is. Guide pulleys just make sure your belt's going where it needs to go. Sometimes you have a system where the belt goes a distance between the two pulleys it's attached to, like the drive and driven, and you might want to make sure that the belt doesn't go all wobbly or have a lot of vibration in it. You might need to make sure that it stays in one place so that it doesn't get caught on some other part of machinery. And that's what a guide pulley is for. It's just there to help keep the belt going where it needs to go. And then you also might have pulleys that have multiple grooves around them, either for multiple belts or to wrap something around multiple times. There's a drum in this picture. It's got a belt wrapped around it several times. And I went and pulled this picture, but it's the wrong picture. If you have a toothed belt, you will need a sprocket for that. So instead of going around a pulley, you're going to have a sprocket. This is not a great picture. It's got a chain and sprocket. There'll be a belt and sprocket come up later on in this presentation. There's also different styles of belts. The four main types that can be sort of divided into are flat belts. Those are ones like the one in the top left picture. And that has a wide surface area. It's good for gripping. It's got like a rectangular cross section, a very skinny flat rectangle. And then there's round ones, and they're used for lighter loads usually. You see the bright orangey looking one in the top right. It's rounded. It's got a round cross section. There's timing belts, the tooth belts, like the one in the bottom left picture. You notice there's some with sprockets on there. That is like in your car when you need things to go precisely where they need to be. You have teeth on your belt so that it goes exactly at the right timing. And then you got a V-belt on the bottom right there. You can see the cross section. It's kind of V-shaped, and there's a very special shaped sprocket that it meshes with. So, or not sprocket, sorry, pulley. So anyways, you've got variations on these themes. You'll see some more variations as we go forward, but those are the main types of belts. And using pulleys, you can switch directions. One way is to put a pulley on the outside versus the inside of the belt. In the top picture there, that little one on the outside is going to go a different direction from the other two. The other way is you can actually cross the belt. So the belt on the top left, look at the bottom picture, the belt on the top left one, that's like going around, let's say it's turning clockwise. The belt, when it crosses, now it's going to be turning the one on the bottom counterclockwise. So you can sort of follow the direction the belt is going, and that'll tell you the way that the outside of the pulley is going to rotate. Some advantages. These are cheap and versatile. There's so many ways you can arrange them. There's a link for a YouTube video. I'm going to put that in the Canvas unit as well. This is really useful if your axles are not axially aligned. That sounds weird to say, but if your axles are not going to be aligned in such a way that gears and sprockets are going to be useful, then you can use a belt. These run smoothly and they're usually really quiet. They don't have a lot of vibration, problems like that. A lot of the time they will provide shock absorption, so if you have motors, loads, and bearings, and parts of your system are vibrating for some reason, or things are bouncing around, it will not put as much strain on the motor. And it can slip if safety is a concern. And the example I use is like, if you have like a system that just has gears, and you're feeding something through it, and your hand gets caught, and it's just gears, those gears are going to pull your hand in and mangle you, and that's not cool. But if you have something with belts on it, and you get your finger stuck in there, the belt might slip around the pulley before it pulls your hand all the way in and hurts you. So it's a safety thing. Advantages. Got some disadvantages though. For example, it transmits less power than gears do or chain drives. You have problems like temperature can really dramatically affect your power transmission. When things warm up, they might be stretchier, they might be looser, they might not grip as well around the belt might not grip to the pulley as well. Also, wear and tear in general and stretching, that can dramatically affect your power transmission. And then slipping can be a negative thing. If you want things to be specifically timed, very precise movements, you don't want that slipping. So that issue, they can partly solve that by using toothed belts instead and using sprockets. So there's a picture of that at top that is actually a belt with teeth in it, and the teeth mesh with the teeth on these sprockets. So that's pretty cool. You find them in bicycles. Here's one on a bike. There was some discussion in class about whether that's a good idea, whether you'd get better power transmission out of an actual chain and sprocket. Probably. But hey, it's doable. People done it. This is an internal combustion engine. This is your timing belt in your car. If you have pistons going in and out of your engine at certain specific time intervals, and your timing belt is actually not aligned properly, if it's wearing and tearing, if it's breaking, your engine could actually have some catastrophic damage and fall apart and fail, and that's very expensive. So you got to make sure your timing belt is not worn through in places. You have some washing machines are belt driven. You got lawnmowers that are belt driven. You've got anything with an engine basically could have a belt driving some part of it. Here's a vacuum cleaner. Our vacuum cleaner is like this one. We've had to change a belt out several times because my hair is like 3 feet long, and if I lose a few hairs and we vacuum them up, they get bound around the beater bar, and then that belt, like in this picture, it sort of starts rubbing around and wearing out, and then it doesn't work anymore. So we've had to change those out ourselves. Also, you might see tank treads or treaded vehicles where the tread is made of rubber. And this is an example of some sort of, lightweight snowmobile thing. And the tread is actually made of rubber. And I was like, I thought about it being metal, and if it's going around and it's warming up because of its movement, that's going to melt the snow, and it's not actually going to grip the snow. It's just going to dig out a trough of wet mush underneath you. Anyways, that is the belts and pulleys presentation. If you all have any questions, let me know, and I will talk to y'all again soon. Have a wonderful rest of your day.